Oil, one of the most important resources of the modern world. Its various forms underpinning modern society, heating our homes, powering our vehicles and our factories. And yet, one of society's greatest resources is also one of the biggest threats to the Earth. Last year alone, over 4,387 million tons of non-renewable oil was consumed worldwide. Consuming this much oil can be extremely damaging to our environment, releasing over 180,000 million tons of carbon dioxide into our atmosphere. But what if there was an alternative to this fossil fuel? An energy source that was clean, renewable, and affordable? Welcome to Chem Brains, and today we talk about biofuels. Biofuels are combustible fuels produced from biomass, which is any organic material ranging from plant materials to animal waste. One of the more common biofuels is biodiesel, a fuel produced by combining vegetable oil or animal fat with an alcohol. It can be derived from a wide range of oils, including palm, canola, olive oil, and many more. Because of this large variety of sources, there are many different physical properties a biodiesel can display, and hence many benefits that can come from using a biodiesel instead of crude oil fuels. For a start, biodiesels are of course renewable. Unlike most fossil fuels that sources are growing smaller and smaller every day, most sources of biodiesel, like beans, seeds, and corns, can be harvested and replanted again and again. In the case of canola, there is also little waste produced in its production. Multiple locations such as MSM Milling and Madola Park focus on producing canola oil, but also use the remaining canola meal to produce pellets. Olive oil also has the potential to reduce waste, as olives are able to produce both olive oil as well as ethanol from the olive stone. In comparison to crude oil fuels, they are also much better for engines. Biodiesel has both excellent lubricating properties, preventing premature engine wear and failure by reducing the friction between the moving parts of the engine. Biodiesel also acts as a detergent, cleaning away sediment and sludge within the engine, ultimately reducing the cost of maintaining your vehicle. Finally, biodiesel is incredibly beneficial for the Earth's environment. Pure biodiesel is entirely carbon neutral, meaning that any carbon dioxide released from a vehicle running on pure biodiesel will be entirely offset by the carbon dioxide captured when the crop is grown. This property can help reduce greenhouse gas life cycle emissions by up to 90%. Further, biodiesel eliminates sulfur emissions and reduces the potential of smog forming by approximately 50%, leaving the air around cities much cleaner and heavily reducing our negative impact on the environment. The presence of these characteristics in a biodiesel is heavily dependent upon the chemical structures found within the original oil. The chemical structure of oils does vary, and hence, so does the oil's properties. Oils are made up of triglycerides. These structures consist of a carbon backbone, known as glycerol, and 3 hydrocarbon chains, which are the fatty acids. It's these fatty acids which determine most of the properties of the final biodiesel. However, in order to convert the oil into a biodiesel, these fatty acids must be broken down and altered. This is done through transesterification. Transesterification places triglycerides in the presence of an alcohol, then uses a catalyst to replace the hydroxide of these fatty acids with an oxygen molecule and a single hydrocarbon chain. This forms fatty esters and glycerol. Depending on the amount of fatty acid present during the reaction, the esters produced can have different effects on the properties of the biofuel. In summary, biodiesel and glycerol are formed from triglycerides and alcohol through the process of transesterification. However, the vegetable oil key to the production of biodiesel doesn't just grow from trees. In fact, there are many processes required before the oil is ready. As there are many different oils, each with their own method of processing, we will focus on 2 common oils found within Australia, canola oil and olive oil. At MSM Milling, the production of canola oil starts off by separating the canola seed from non-essential materials. then placing the seed into a crusher where it can be pressed against a choke by a rotating screw shaft. This process removes the majority of the crude oil from the seed. This crude oil is then both chemically and physically refined. The refinement works by reacting hydratable phosphatides in the gums, rendering them water soluble. This allows the gums and soap mixed with the oil to be separated out through the use of a centrifuge. The oil is then bleached, removing a variety of substances by filtering the oil and passing it through a bleacher. Finally, the oil is deodorized to remove any remaining oxidation products, pigments, and free fatty acids. This is done by heating and cooling the oil, as well as passing the oil through a vacuum. Olive oil follows a similar but simpler process. The olives are initially washed to remove any dirt, weeds, or twigs, before being passed through a grill. The cleaned olives are then placed into a grinder like that with canola, where the screw shaft grinds the olives into a pulp. This pulp is then placed within a centrifuge, where the oil is allowed to pass out of the pulp through a fine mesh. This allows for the oil to be siphoned off without the pulp. Pure, unfiltered oil is considered the most valuable, which is why the olive oil does not need to be filtered like canola oil. It is these processing methods, however, which result in the disadvantages of biofuels. The initial processing of the vegetable oil generally requires large amounts of water to irrigate crops, clean the seed or fruit, and to filter out any unwanted substances within the oil. This can place unsustainable pressure on local water resources. The initial cost for starting biodiesel plants is also extremely high in the current market. With the majority of demand for fuel being focused on crude oil fuels, it is difficult to receive the optimal investment to start a proper plant. Some biodiesels, such as olive oil-based diesel, also still requires some research before being a viable replacement for crude oil diesel. Ultimately, biofuel, specifically canola biodiesel, is the perfect candidate for a substitute to crude oil fuels, benefiting our environment, our vehicles, and our future generations, shaping a better, healthier world.